Hello, today we are going to do chemistry and we will be starting off with some basic mole concept. Now, we'll first start this off by defining what an atom is. An atom is the smallest independent unit of matter. So we'll just write that here. Smallest unit of matter. Now, molecule. Molecule is basically a collection of atoms. So, molecule molecule is a collection of atoms. Okay. Now we'll start off with what a mole is. Okay. I'll keep this in red. Mole. Now, a mole is an Avogadro number of particles or objects. Now, for example, if you go to a bakery, you tell him, I want a dozen eggs, and he automatically understands you want 12. If you go and tell him, I want half a dozen eggs, he automatically knows he has to give you 6. Just like that. If you go to the shop and you ask for an Avogadro number of eggs, now Avogadro's number is 6.022 into 10 to the power 23. Okay. So if you ask for an Avogadro number of eggs, he'll give you these many. So the Avogadro number is nothing but a unit of quantity, like a measure of quantity. So if you go, like how you, if you say a pair, people automatically know you mean two. Like that, if you say Avogadro, the Avogadro's number, they automatically know 6.022 into 10 to the power 23. Okay, so now that we know what Avogadro's number is, uh, 1 mole is equal to 6.022 into 10 to the power 23. I'll say atoms, molecules, or particles. I can say particles, right? Now, just for clarification, I'll write it down again. So 1 mole of, let's say, X is equal to 6.022 into 10 to the power 23 X. I'll write Avogadro's number here as well. So 6.02. This is also denoted as N. Make sure this A is capital, or otherwise you'll think you have written sodium. Okay, so now we know what Avogadro's number is. Let's let's move on to how to figure out how many moles there are. So I will wait. Let me change the color of pen. Okay. So um, number of moles. All right. if they've given the mass, like for example, they have said 1.6 grams of O2 gas. Now we have to find out number of moles. Finding out number of moles is pretty simple. We know the molecular mass of oxygen is of oxygen gas O2 is 32U. So for single oxygen it's 16, and O2 gas it will be 2 into 16, just 32U. Now 1 mole of O2 gas is equal to 32 grams. So naturally, to find out number of moles, you take the, where's the cursor? You take the mass given to you, which is 1.6 grams. We divide it by molar mass of the compound slash element, and then you can see by this we get 0.05. Yes, so we get 0.05 grams. Not grams, moles. Sorry. Now, I'll take blue again. This was point number 1. Point number 2. What if they given you the volume? For example, we have 44,800 milliliters of water. We have to find how many moles of water there are. So it's simple. Now the volume, the molar volume of the ideal liquid at room temperature at 1 psi pressure, atmospheric pressure at sea level, you get 22.4 liters. This is the ideal volume of a liquid at sea level room temperature. So if you convert this, where is the cursor, man? Okay, if you convert this, you get 22400 ml. So here on, this would be pretty simple as well. You take the volume given to you, 44,800 divided by 22,400. You can see this, we have 2 moles of water. Let's take black again. Now, a third situation is you're given the number of particles. Come on, man, select. Okay, given the number of particles here. So 3. Let's imagine we've been given 12.044 into 10 to the power 23 particles, and we have to find out how many moles these are. So that should be pretty simple. We discussed earlier that 1 mole has Avogadro's number of particles, as we saw here. We'll come down. So we divide number of particles we have by Avogadro's number, which is 6.022 into 10 to the power 23. You'll see all of this cuts out. We get 2. Hence, we have 2 moles. Okay, good enough, good enough. Fine. Now, this is about it. Now we'll do another example. I will choose the color. Another example. Let's say we have C6H12O6. We know this is glucose. We need to find how many atoms there are in 0.1 moles of it. Okay, so if we think about this logically, each uh, each molecule of glucose here has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So we get 24 atoms in one molecule. Now, as we saw earlier, we have to get 0.1 moles of it, and one more mole will be Avogadro's number of molecules, right? So to find number of molecules, we do 24. Let's write number of atoms actually, not molecules. Number of atoms equal to 24, which is number of atoms in one molecule, into 0.1 and Avogadro's number. 0.1 because you have to find number of atoms in 0.1 moles of it. So we get this as 2.4 Avogadro's number of atoms. All right. We'll do another simple example. I'll choose a color and take orange. If I could find the cursor, that is okay. Example C12H24O11. If I'm not wrong, okay, that this is the right formula. Okay, C4H24, C12H24O11. Okay, let's find 0.2 moles. Number of atoms in 0.2 moles of it. Right. So we'll do the same thing we did again. One molecule of this this compound will give us 12, 24, 11. This will be 45. Now, one mole. Where's the cursor? One mole has these many molecules, Avogadro's number of molecules. So, number of atoms is equal to 45 because that's number of atoms in one molecule into 0.2 moles of it into Avogadro's number, which is 9 Avogadro's number of atoms. Right, cool. Now let's move on to types of masses. This should be pretty simple. I'll choose light green for this. Make a heading here, types of masses. We will start off with atomic mass as we saw earlier. atomic mass, gallant line. This is the mass of the individual atoms of an element. So it's measured in something called as AMU, which stands for atomic mass unit. Now, second type of mass is molecular mass. This is the mass of one molecule of an element. It's measured in U, which stands for unified mass. Then we have molar mass, which is, if you just follow the trend, it's the mass of one mole of an element or a compound. It's measured in grams mass of Avogadro's number of particles measured in grams. That looks like a U. 1 second. There. Then we have formula mass, which is used for ionic compounds. For ionic compounds measured in U. Example. A common example of an ionic compound is NaCl, sodium chloride table salt, and it is measured in U. We know what U is. It's atomic mass unit. Then we have gram atomic mass and gram molecular mass. These are not very specific. This is basically the mass of the molecular mass, the molar mass, and the atomic mass, just expressed in grams instead of AMU or U. Okay, so we'll do some more examples of finding the molar mass of substances. I think we've had enough of this color. I'll take a red. Some questions. Find molar mass of the following substances. Alright. The first one we have here is C12H22O11. This is known as sucrose. Now, to find mass of the molar mass of this substance. So we have molar mass is equal to, we have 12 of carbon. So 12 units of carbon whose weight is 12 plus 22 hydrogen atoms whose mass is 1 plus 11 oxygen atoms whose mass is 16. If you work this out, we get 342 grams per mole. So the 1 mole of sucrose will weigh this much. So that's a lot. We'll do another example. We have NaOH. This is sodium hydroxide, pretty simple. Molar mass is equal to mass of Na is 23. So 23 plus mass of oxygen is 16, mass of hydrogen is 1. So you get 40, 40 grams per mole. You can write grams per mole as G mole to the power minus 1. You should understand this as well, the same thing. We'll do one last example of urea. Now, urea is written as NH2 CONH2, right, in brackets urea here. Now, if we compress this formula, we get N2, because these are repeating, H4CO. Just because this is normally not represented like this, but just for the sake of convenience, we are compressing the formula. So we get 2 nitrogen, not H, M. Molecular mass is equal to 2 into 14 plus there's 4 hydrogen, so 4 into 1. There's one carbon 12. There's one oxygen 16. So we get 28, 4, 12, 16, which is 60 grams per mole. And we'll do another type of question here, slightly raising the difficulty level. I'll take black. Okay. Slightly raising the difficulty level. Where's the cursor, man? Okay. So let's take C6H12O6 again, this glucose, and I'll write this again, 1.8 grams of C6H12O6. Now, first let's find out number of molecules. So as we first we have to find out number of molecules. First we'll just find out how many moles of glucose we have here. Okay, so as we saw earlier, where did it go? Yes, here. I'll just circle this again. We will do this. Today is a colorful day, isn't it? Okay, we are back. Black again. Number of moles. Fine. So let's get the molar mass. C6H12O6. Fine. We have molar mass 6 into 12. 12 into 1, and then 6 into 6 into when it was 6 into 16, we get 180 grams. grams per mole, that is. So to find number of moles, is 1.8 by 180. We get 0.01 moles. Now, if you look at it rationally, 1 mole was equal to 1 Avogadro's number of particles. Right. So 0.01 moles would be 0.01 into Avogadro's number of particles. Right. So we got our answer here. It's 0.01 into Avogadro's number. I'll just write molecules here. Right. 0.01 Avogadro's number of molecules. Now the second part of this question, find number of atoms. This again, we've done this before. C6H12O6. One molecule of C6H12O6 has 6 plus 12 plus 6 equal to 24 atoms, right? And we saw earlier that we have 0.01 moles of it, of C6H12O6. So number of atoms is equal to 24 into 0.01 into Avogadro's number. So we have 0.24 into Avogadro's number of atoms. That was pretty simple. Now, the third part, number of carbon atoms. Again, this will be similar. It's C6H12O6. We have 6 carbon atoms. And again, we do the same thing. Number of carbon atoms equal to 6 into 0.01 moles into Avogadro's number. 0.006 Avogadro's number of carbon atom. That is pretty simple, as well. Okay, so we'll do another example. This one will be slightly trickier. Let's take NH4 plus. All right, and we'll take 1.8 grams of it. Now, for this, you have to find the number of protons. Find number of protons and number of neutrons. Not neutrons, number of electrons. We'll get to neutrons later. Okay, so first let's number of protons. Protons is equal to number of electrons for a neutrally charged particle. I'll put that in brackets. Neutrally charged particle. Fine. Switch back to blue. All right. So another thing is this. Just get the eraser. This is basically the atomic number. So atomic number of N is 7 and we have H4. Now usually it would be 1 but we have 4 of hydrogen. So 4 into 1. So you add 7 plus 4 you get 11. Now this is 1 unit of NH4. We want the molar mass. I mean the number of protons in a mole. Alright. So anything related to a mole you just multiply this by Avogadro's number. So 1 mole is equal to 11 Avogadro's number of uh, protons. But 1.8 grams, it means the weight of NH4 will be weight of NH4 will be 18 grams. So weight of nitrogen is 14U. Weight of hydrogen we saw it's 1 into 4. So molar mass will be 18U. Hence, if we divide 1.8 by 18, we have 0.1 moles present here. Let's underline this. Naturally, 1 mole is 11 into Avogadro's number of protons. 0.1 mole will be, if you divide 11 by 0.1, you get 1.1 Avogadro's number of protons. Fine. Now let's look at the electron part of this question. We have done this. But number of electrons, fine. Now if we look at the charge we had put out, this is a positive charge, right? This positive charge signifies that the molecule here it lost an electron. Well, for more clarity, the electron is negatively charged, right? Electron has negative charge. So if you have a total charge, let's say it's neutral, but a positive and a negative uh, give you a neutral charge. But if you remove this negative charge, you just get a positive, and that is what has happened here. It lost an electron, and hence it is slightly more positive than it was earlier. Now focus on the part where we said it lost an electron. So in a neutral charged particle, the electrons would be equal to the number of protons, right? We wrote it here. In neutral, for neutrally charged particle, number of protons is equal to number of electrons. But as we said earlier, it lost one electron. So we take 11 and we subtract 1 and we get 1 mole. Come on. Okay. 1 mole is equal to 10 into Avogadro's number of electrons. right? But then again, we don't have 1 mole, we have 0.1. So 0.1 mole is equal to divide 10 by 0.1, we get 1. So we get Avogadro's number of electrons. I will underline this very quick. Bam, bam. Fine. I hope this was clear, not too hard to understand. Then we'll just revise. We'll revise from this and then we'll move on to one last question. An atom is the smallest independent unit of matter. A molecule is nothing but a collection of atoms. Now, 1 mole is basically a way of saying the quantity. Like we said earlier, a dozen is 12, a pair is 2. Just like that, 1 mole is 6.022 into 10 to the power 23. It may be atoms, molecules, particles, whatever. For an example, 1 mole of X would be 0.06.022 into 10 to the power 23x. And this number, 6.022 into 10 to the power 3, is known as the Avogadro's number. It is written as Na for convenience. Now, how to find the number of moles? If you are given the mass of the sample you are taking, you divide that by the molar mass of the subcompound or molecule. If you are given the volume of the sample you are given, uh, the ideal the volume of 1 mole of the ideal gas or liquid is 22.4 liters. So you divide the volume given by 22.4 and you get the number of moles. Secondly, they are given the number of particles. This is very simple. You divide it by Avogadro's number and you get number of moles. We did an example here of how to find out number of atoms. We did another example. Now we have types of masses. We went through atomic mass. It is the mass of one atom of an element. It's measured in AMU, which stands for atomic mass unit. Molecular mass is the mass of one molecule of an element or a compound. It's measured in U, which stands for unified mass. Then molar mass is the mass of Avogadro's number of particles. It's measured in grams. And formula mass for atomic ionic compound is usually used for ionic compounds. It's measured in U. So as it's technically a molecule, and it is U stands for, as we saw earlier, unified mass. Now after this we have gram atomic mass, gram molecular mass, and gram molar mass. Well, gram molar mass is practically the same thing. It's gram formula mass. So it's basically all these masses here, with the exception of molar mass. As you can see, atomic mass is represented in AMU, molar mass is in U, and formula mass is in U as well. It is nothing but representing the same mass but in a different unit, and that unit will be grams, as the prefix to the name says, gram atomic mass or gram molecular mass. Now we did some questions here. Find the molar mass. We saw how to do that. We we saw a number of we solved this complex problem. Then we solved this one, which find the number of electrons and find the number of protons. I'll take green here, make this tick. Okay, so we'll move on to the next question now. I'll do it in blue. This is the last question for the day. We have let's take the carbonate ion. Uh, okay, we take the carbonate ion question. We have 6 grams of CO3, 2 miles. We've done this type of question before, but it's here we had plus, which means it lost an electron, and here we have 2 minus. Now, 2 minus means it has gained that negative charge. It means If you take the electron, which is the negative particle, you will obviously get a negative charge. So I'll put it in brackets here. 2 extra electrons. Right. Now, what do we have to find here? To find the electrons, and we have to find neutrons. This number of electrons, and we have number of protons. Not protons. We did protons earlier. This time we'll do neutrons. Right. Okay. So let's start off from the basics. We have to find out the number of grams, right? Number of grams we have to find out. So molar mass of CO3 2 again we'll ignore the charge when we are calculating the weight, because that doesn't imply anything. It doesn't contribute to anything, the charge to the weight. So we have carbon, which is 12. Then we have two oxygen, which is 6 into 2, 32. We get 44 grams per mole. Right. We have three oxygens. Oh, my bad. We have 48, and that gives us 60. Now, number of moles will be 6 by 60. We have 0 0.1 mole. Right. Now, again, we'll do the same thing we did earlier. First, we'll find number of protons. We have carbon, whose atomic number is 6. Then we have oxygen, whose atomic number is we have oxygen, whose atomic number is 8. My sorry, whose atomic number is 8. So 8 threes are 24 plus 6 is 30. We have 30 protons here, right? But this says 2 minus, right? So number of electrons in CO2 minus CO CO3 2 minus is equal to 32, because see, like we saw here, we have two extra electrons. We add that to here, this we get 32. Now again, this is 1 mole of CO2. I'll write this again properly. Get some space here. Number of electrons in CO3 2 minus is equal to 32. Now 1 mole of CO3 2 minus will have 32 into Avogadro's number of electrons. But here, as we saw earlier, we have 0.1 moles. So 0.1 moles of CO3 2 minus will be equal to 3.2 into Na, Avogadro's number of electrons. But now we got the answer here. I'll underline this. maybe closer because we need that space. We'll find number of neutrons. Now, the atomic mass is number of I'll write that as well. Atomic mass equal to atomic number or uh, protons plus neutrons. Now we saw number of protons here. I will make this. We saw number of protons here, right? So atomic mass, well, molar mass of CO3 2 minus or CO3 2 minus is equal to 60 grams. All right, and we saw that it has 30 electrons. Just write molecular mass here, it will easy thing, make these things easier. Molecular mass, well, let's just write mass of CO3 2 minus is 60U. Right. So 60U will be 30 protons, which we saw earlier, plus a mystery number of neutrons. We get n is equal to 30. So now we know there are 30 neutrons. But that's 30 neutrons in 1 mole. I mean, that's 30 neutrons in one molecule. So 1 mole of CO3 2 minus will have 30 into Na of electrons, I mean neutrons. But again, we have 0.1 moles of CO3 2 minus, which will be 3 into Avogadro's number of neutrons. Okay, so that is it for today. Thank you.